Okay, thanks everyone for joining today. We'll get started here in just 1 second. I think as folks kind of trickle in, I don't know, Maher, have you made it to the webinar? Make sure everybody's in. Let me make sure. There it is. Okay. All right. Well, thanks everyone for joining today. Really appreciate it. Glad to be here. It's myself today and Maher Asfar. So we're from product marketing, and we're product marketing engineers here at the VCF division in Broadcom. And I'm Vince Riccio, and Maher will be doing the demo today. So kind of what we're going to do today is I'm going to go through a few slides, talk about, just set some context, give you sort of the up-to-date and latest thing that we're doing around our self-service consumption strategy, primarily with obviously VCF automation. And then Maher will come in and do a demo showing us how to consume and take advantage of some of those capabilities. So without further ado, let me go ahead and get started. If my presentation will go. Okay, there we go. So before I kind of jump into some of the other slides, I want to kind of give just a little bit of an overview of what we're doing, where we're focused with the product, and a little bit about what we've been working on. So currently, the VCF automation solution that comes with VMware Cloud Foundation provides really this self-service capability using various methods for users to consume from. So for instance, the UI, CLI, or API. And we've also introduced some services that you'll see today or some UI capabilities around deploying services. So for instance, let's say you just need to deploy a VM, you can do that. If you just need to deploy a VKS cluster, you can go in, there's a form to do that. If you need to go in and deploy a database using our DSM technology or data services manager technology, that is there. So this modern cloud interface is really kind of one of the main things that we're very much focused on, and providing that self-service infrastructure as a service capability, whether it's a catalog or CLI and so forth. And then some of the categories down here or buckets around governance and policies, right? Automation has had a governance and policy engine for some time around approvals and leaves times, day two actions, and so forth, and even some agnostic capabilities with the blueprints. And now we've also introduced a couple of things here, especially in the what we call the All Apps org, which is focused on custom Kubernetes definitions to deploy stuff. Is we have an infrastructure as code capability of creating policies for those Kubernetes objects, and that's based on the validation of mission control settings and CL language from Kubernetes. So a little bit of integration there, which is nice, and continuing down the infrastructure as code section as well. So we still have the blueprints that can be based in YAML and so forth, and we also will create the Kubernetes YAML as we deploy things and so forth. Or you can just still use our blueprints, source control them, and get and continue to use that kind of functionality if you're familiar with that. Now, the other thing that we've been doing with the product for some time now is integrating in our private AI capabilities. And part of that is a really nice quick start wizard that allows you to quickly set up the catalog service, so folks can go in and deploy, AI rack clusters and workstations, and have that platform to be able to do their development work and build their models and so forth. So that's been really nice. And then also private cloud services. So I'll talk about a little bit more about that in another slide here as well, but we've introduced a really rich set of services to where when you go into the product, if you need, like I mentioned, database service, or if you need like a networking service, or let's say a pipelining service, or secret service, or cluster management service. There's a number of services in there that we're introducing, and you may see one of those today if we have time around the database. So just kind of building out this rich set of services. Again, I have another slide on that, so I'll focus a little bit more on that during that slide. Now, the other thing that we've introduced in 9 with VCF automation, especially, is the tenant management capabilities. And we actually now have a provider portal. I don't think we'll have time to really demo that today, so I'll just kind of talk to you a little bit. We have a provider portal now outside of just the organization portals that you'll see today. And that tenant portal allows a provider admin or enterprise IT admin to manage multiple organizations, which are like tenants. Basically, they're tenants, and they're isolated or can be isolated. and so forth. And mixing technologies that we've had in the past in there has really given us that more granular tenant methodology and capability. So just kind of be on the lookout for that. And then content management, that was another big thing that we kind of introduced here, was the ability to more easily manage content, not just from the organization or tenant itself, but across the tenants if you need to. There's content libraries within VCF Automation that will map to a content library in vCenter. And then you can upload images right from there and start to consume them. And you'll see more expansion on that as we go along. Orchestration extensibility is still part of the platform. So Orchestrator's right there in the UI now. um, there's no separate UI for that. That's right there inside the product. So you can integrate your workflows and your orchestrator workflows very easily now with the catalog and so forth. And then workload lifecycle management, continuing that capability, right, where day two actions, as well as event broker type of services that can automatically do things in the system based on events that happen during the lifecycle of a workload. And the other thing that I want to point out here a bit is on the right, where we look at the personas. These are really, generally personas, like I mentioned, that we're really focused on, especially that enterprise IT admin, like I mentioned, and the org admin. So the enterprise IT admin will focus on managing all the organizations, and then the org admin will focus more on managing the organization itself or the tenant that they are responsible for. And you'll see that today a little bit. I believe my hair will probably be in there as an org admin and maybe even as a developer or advanced user, but either one, or will do things within the organization, right? So as we go up a little bit, you'll see the LOB admin, that could be your project administrator, because even inside an organization, you can have different projects and maybe managing different lines of business. And there could be a project admin or an LOB admin there as well. And then, of course, the developers. So when we come to the users, when in terms of the user roles, there's a couple of different kinds. There's kind of a basic user that can just go in and do and initiate requests from the catalog for that self-service, more easier way to kind of do things. And then there's also an advanced user option for folks that may need to go in and deploy Kubernetes resources right from the form, and they'll need to be a little bit of an understanding on that. Now, the VCF automation, of course, still sits on top of vSphere. We're still consuming those vSAN policies, still consuming those NSX constructs, even more so, especially now with the VPC and things like that. Okay, so just kind of going back to those services earlier when I talked a little bit about the services and so forth. This is just a little bit of a snapshot of just a couple of things. So one thing you're going to see today in the upper left-hand corner is going to be the main services that we have in the system, which will be the VKS, the VM service, and the VKS service. Those are generally what VCF automation will help you out with out of the box. And there's obviously the ones underneath too, the network storage and load balancer services are there out of the box as well. In the demo today, we should see a VM getting deployed, may be able to see a VKS cluster get deployed if we have time as well. But those are basically custom resource definitions for Kubernetes that we have that allow us to deploy VMs as a, using a Kubernetes manifest. And it's a full, VM, and it uses a general OS just like you would with any other VM. And but you can manage it using Kubernetes YAML and also the self-service IaaS form that you'll see in the demo. And I found that to be very helpful for me and in a lot of things that I'm doing as well in our labs and so forth. And then deploying, fully conformant VKS clusters, right? Kubernetes clusters and so forth, and being able to manage those. And on the right-hand side are some of the ones that, will be available. And one that we might see is the data services one in the lower right. That's the ability to deploy and manage open source databases. And then there's things like, Argo CD for pipelining, Harbor for image registry, and so forth. And the secret service also comes out of the box as well for managing secrets across your Kubernetes objects inside your supervisor. So a lot of different interesting things there. Now, the other one that or let me kind of actually talk about this first before I kind of jump into the architecture, is really kind of the various ways that we can consume, okay? So when we look at, earlier I mentioned that modern cloud interface and that we have these capabilities to, you know, like consume, right, the modern cloud or the private cloud, and these are just some of the capabilities that we're looking at. Right, one is the catalog API. We've had a catalog in the automation system for some time. We've had a self-service role-based access catalog that can not only allows folks to go in and deploy, like, let's say, workloads and operating systems, but also anything as a service, like with orchestrator workflows and et cetera. And now we actually have a really nice way to take an image in your content library and publish it right to the catalog. So if you have an image like an Ubuntu image or something, and you want to just deploy that over and over again, we have an easier way to kind of do that, and we still have those blueprints that we've had traditionally as well. And then the other thing is the Kubernetes YAML, right? The cloud services using declarative YAML. So what you'll see in the product now is there's a services section, and underneath that you'll see namespaces. And as you switch between namespaces in the UI, you'll have the ability to deploy Kubernetes objects within those namespaces, such as virtual machines and so forth. And as you build those out and use those, then it will build out the Kubernetes YAML for you, and you can reuse that into the blueprints if needed. And also when you deploy those Kubernetes objects, not only could you manage them through the UI, but you can run traditional kubectl commands against those objects. So and we also have something called the VCF CLI now as well, which is really providing a very robust way to manage objects in there as well. So for instance, if you wanted to view your clusters, you could do like VCF CLI clusters and then view the clusters, right? And if you wanted to go look at your deployments, you could still do something like a kubectl and then look at your deployments that way or manage those. But at the cluster level and at sort of the platform level, that VCF CLI is really helpful. The other thing that we have, and we've had for some time actually in the automation, but we're revamping it and have been revamping it for 9, is the Terraform provider. So the Terraform provider is available out on the Terraform repo, and what that basically does for you is allows you to automate the configuration and sort of the setup steps sometimes of automation itself. These are constantly being built out, and new functions are coming in. But generally, what these are used for, or the Terraform provider is used for, is okay, I've got VCF automation maybe installed, but now I want to go ahead and set everything up in a certain way and make sure we have that state saved somewhere. So if we have to redo it, we know exactly how we need to set up automation again if needed, especially with the organizations and projects and things like that. So very helpful for our customers. And then something that we've introduced recently is more of a kind of an, let's say, an integration or sort of a way to use. We've sort of been investigating this, and I think we have some documentation out now and some blogs around how we can use Argo CD as a way to leverage a Git repo. So essentially, you put your Kubernetes manifests in your repo, and then you're going to use Argo CD to just do a continuous deployment of those pieces, right? So if you want to deploy VKS cluster, you want to deploy that infrastructure to manage your applications and stuff like that, you can use Argo C to do that and have that continuous delivery model. Okay, let me just do one thing and see if I have time to go over. Okay, I think I have a little time to go over the next slide, which is going to be more of the architecture side. Let me just break it out. Okay. All right, so here it's kind of a busy slide. I'm not going to talk to every piece in here, but I'll kind of give you just the general idea here. And this is helpful to understand, especially because we're not going to have time to really dive into the provider side of everything and how it's all set up. You will see some of these things though as we kind of go and work inside the organization. But essentially what we're doing today is, within vSphere, you have obviously vSphere clusters, but you can turn those into zones, right? And in those zones, we can sort of use that as sort of an extraction on the cluster, so we can tie those to regions, right? And so each zone will represent a cluster today, and then essentially we can take that and then make one or more of those into like what we call a supervisor, and then we can have the regions consume that. So when we look at sort of how we're setting up the zones, those could be like US West, US East, right? That kind of thing. I'm sorry, your regions would do that. Your zones will just be your clusters, right? But that region is that abstraction layer on top of your zones. And that's what you kind of build out in VCF automation. So your region could be like US West, and the other region could be US East. And it would consume some of those zones, which are the clusters. And that just gives you the ability to move workloads to the right location. Maybe there's certain capabilities of the clusters in that region, but it does give you sort of that way to separate things out from that region capability. And on top of that, the organizations can then consume through the region they'll get what we call a region quota, and the region quota will basically say, hey, here's how much resources you have out of the zones available to this particular organization. So we can slice up, carve up some of the resources for these organizations by using that region construct. And then on top of the organization, the way that folks are going to actually deploy, they're going to deploy into a namespace using, when we go into the organization type that we're going to show today, they will actually deploy into a namespace, and then they can deploy their VMs and their applications and stuff there, and so forth. So that's kind of the idea of it. We're just really sitting on top of that sort of supervisor control plane, carving it out for these organizations, and then allowing them to deploy into namespaces, vSphere namespaces, and deploy those applications in that modern way that developers are familiar with, and so forth. Okay, so I know I went through a lot pretty quick, so we have a demo to go through as well. So let me go ahead and stop sharing. And Maher, I guess I will go ahead and kick this over to you, if you're ready.
Yeah, sounds good.
Okay,
Hello,
thanks.
everyone. Thanks for joining us. Okay, so based on the last slide that Vincent was showing in terms of the component, let's go ahead and map that to an actual environment that we have in our lab, and hopefully we don't have tons of time to go through and touch on everything, but the idea is that we have two management domain here. We have VCF instance, as you can see at the bottom of the screen. This includes two management domain. We have a management domain where we've activated the supervisor, and I'll talk about this in a second. And then we have a workload domain, and these domains, being the management and the virtual infrastructure, have dedicated vCenter and dedicated NSX for the network boundary. On top of these two domains, and on top, we have VCFA, of course, VCF automation. And this is where we take the region and we make the supervisors that's talking to the same NSX instance as part of this region. So this can be geolocation, like US East versus US West. US East here, this region includes the supervisor in the management domain, and then the US East includes the supervisor in the workload domain. So what does that mean? That means all the resources that we have in terms of CPU, memory, storage is all available in this region. And when it comes to VCFA and on top, we can now configure what we call a tenant or an organization, as you will see in the UI in the demo. So we got Acme Org here as the base company, basically, and we see two region quotas. So we've allocated region quota from US West, and so the CPU cycles and the memory footprint here and the storage is coming from zone 1 in US West. Therefore, any thing that we create in this region is going to go on the management domain. And then same thing for the US East region quota when we allocate. Here we have the same kind of virtually the same configuration except for the storage, where we gave them less storage, for example. But this can be anything depending on the business needs of the organization or the tenant. Also including and alongside the resources, we have the regional boundaries. So these regional boundaries are based on building blocks, like what external IP spaces they need to use to get to the external world, what edge clusters for south-north traffic routing. So all this stuff is automatically assigned and allocated to the organization to contain these workloads within specific network domains. The Acme sales here is a BU, or let's say a line of business, as part of the base company Acme, and this is the sales organization, for example, and they only have region quota that was assigned by the provider admin that consume resources in the workload domain. Now, within these organization, you saw Vincent on the last slide mention namespaces, and namespaces, think of them as just resource pools that we deploy infrastructure into. When it comes, like if you're looking at this from a vCenter perspective. So we create projects, and these projects allows us to map users to resources. So in this project, we've created two namespaces or two resource pool. The Acme development is created in the US West region. Therefore, it's going to consume resources from the region quota from US West. And then Acme production namespace is created on the US East region. Therefore, it's going to be created on the supervisor, for example, in the VI workload domain, and therefore consume resources there. So now that we kind of said that, if we actually look at this in VCF automation, And we'll touch in really quickly. I'll go into the provider portal and login is as the provider admin in here. Let me grab the password. So once I log in here and exactly map to the diagram that we just saw, you will see that in the organization, when you log in and you install VCF, we automatically detect these dedicated vCenter and NSX Manager under the connection page. So here we see our vCenters connected and up and running in a second, enabled and connected. And we see the NSX managers also in each of those, one from the management domain and one from the VI workload domain. This is a region. So we created US East and US West, and we've included those supervisors accordingly. And then on the organization, this is where we create our tenants. And we have Acme, the base company, and we have Acme sales of type all apps. And let's get into the two types of organization that you can create here. The VM app is, think of this as a continuation and backward compatibility for our existing customer who are using ARIA Automation 8.x. So when they upgrade to VCF Automation 9, they will be placed in this VM apps, not the focus of this session specifically today, but we want to talk about the new experience, which is the all apps organization that supports running application of all types, whether they are traditional, on virtual machines, or container-based. So in the Acme organization, we can see our region coda. So you can see a region coda for US East with the CPU resources reservation, etc., that we saw in the diagram, and one for the other region, US West. The network boundaries also is kind of contained and configured for both of the region. Now that we have all this set up and we've allocated the resources, let's say the line of business paid for and needs, then we can go into their organization portal and hand the keys to the organization administrator. Now we're not getting into the setup piece by piece here. I did share in the chat the VCF Automation 9 video series from Zero to Hero. So there are 5 parts. Make sure you bookmark that, watch those. It'll take you through every step of the setup in terms of the handover from the provider to the organization administrator. Again, we're seeing all the menus here because we're logged in as the admin, and then we have access to the services because of we've created those projects and we've created those namespaces. On the overview page, you can see I have access to all the different namespaces that I've created. And we only have one project here. And with the integration of VCF operations, we can also get a glimpse into the total utilization that this org is used so far in terms of CPU, memory, and storage. We can also filter this by project or namespaces. So I have multiple namespaces, which we saw in the namespace selector. And you can see the consumption and usage or total utilization and the top 3 consumer for those namespaces across CPU, memory, and storage. So let's go ahead now and talk about what the supervisor and the control plane did for us. This is what we call, this is a new trend. So as you, just a bit of history here, Kubernetes declarative API model already we know transformed the way how organizations build and operate modern applications today. But in the past few years, there is a really industry trend that risen up and emerged, and the same Kubernetes model that was being now used for applications exclusively is extended beyond containerized workload and into the world of infrastructure itself. So when we get access to these out-of-the-box services, what we're actually talking about here is provisioning a virtual machine using a Kubernetes-style API. And in this demo, for example, when we log in as a project administrator or a project advanced user, we have access to these services. There are core services that comes out of the box, and there are their extended services like databases, secret store, Alvi load balancer, etc., that we can extend by enabling those operators on the supervisor and deploying those services so we can make use of those custom resources definitions that we make available within these namespaces. Now, if we go into the create virtual machine, if you're going to experience and interact directly with the services, that's one of the approaches in terms of the consumption experience for users. is that we go through the UI, or we can use the VCF CLI also. The minute I go in, I'm kind of presented with which source type do you want to deploy from. You want to deploy from a template like an OVF or an OVA, or ISO format if that's what you want. So we have a lot more options in the OVF. So we're gonna keep selecting that and scroll down and be able to select the VM name. There's one generated for you, but you can always change it. And then move on to selecting our, for example, OSs. This is the Ubuntu 2204 or 18 or 24. And as I go and move on to selecting my virtual hardware specification through something that we call VM class, which means t-shirt sizing. So here I have some of which I've enabled. So the org administrator can tailor what the user sees from the approved standardized sanctioned images and the approved t-shirt sizing that their standards request or calls for. Everything I do in the UI will automatically be generated as a Kubernetes manifest for a new CRD or custom resource definition called virtual machine. Obviously, Kubernetes or upstream Kubernetes today don't have a kind such as this, but in Broadcom, we've actually configured and developed custom resource definitions to consume infrastructure using Kubernetes style API. And in this case, we're leveraging the virtual machine CRD. This is operated and managed by the VM operator, and VM operator is something that is running as a service on the supervisor. So it understands the desired state that we're setting here under specification and makes that desired state an actual state. If we go into the advanced settings, we have the option to specify additional disk volumes that if you want to associate with the VM. We can also create load balancer using existing or new load balancer. So for example, let's say at as simple as an SSH on port 22, and the destination is 22 on the virtual machine. I'm going to create a load balancer. This is going to expose this port and this protocol on the load balancer. The reason you might want to do that depends on what network or what VPC subnet in VCF9 this virtual machine is going to connect to. If you connect this to a private VPC subnet, you will not be able to reach the virtual machine because that VPC subnet is behind your transit gateway and your VPC gateway where the namespace is actually created in. So if you want to access it, then you have to create a load balancer. This load balancer will have an IP from the external IP space assigned by the provider that will allow you to interact with this IP and communicate with the IP to access the virtual machine, leveraging the ports that you define and in your load balancer. And in this case, this is the virtual machine service custom resource definition. This is, of course, another Kubernetes YAML that got created because we've created a load balancer. Now, if you're connecting or planning to connect this virtual machine to a public subnet that would advertise this IP address and grant the VM access, then you will be able to reach this VM and you will not need load balancer unless you're really provisioning more than one virtual machine and you want to balance your web traffic across them. Another important here is the customization. We support 4 different bootstrap, out of which Cloud Init and Sysprep for Windows, Cloud Init for Linux. These are the most top 2 common used bootstrapping. Gone the days that we use custom spec. So this is bring your own image from your preferred vendor, let's say Ubuntu, and then use the cloud image and bootstrap it with Cloud Init, for example. You have 2 experiences here. We can use the guided inputs where I can go in and define, for example, enable the default user Ubuntu, or maybe create a user that I want. And I want to also grant this user SSH or add them to the sudo group. So as I'm doing this and adding it to sudo, for example, I can provide the SSH keys, the public SSH key that I want to use with my private key. But the minute I do that stuff, right away under Bootstrap and in the Bootstrap secret where we save our in the virtual machine, we have all the Cloud Init configuration in line that will allow us to bootstrap this VM, create this user, and perhaps enable SSH and execute the commands that we want. Like, for example, let's say we'll just do echo hello world and pipe that into a temp folder. Welcome to text, and then add this command. So you can add any command you want to run in Bootstrap. Or this is one way of doing this things. Other ways, we can go to the raw configuration of your cloud config and simply just dump the cloud config data that you want right into here. Here you can basically put all kinds of cloud in it. Payloads like downloading, setting your repos, downloading your packages, running commands, writing files, and executing your commands. Once you're ready, you can move to the network configuration. And this is where I said you can decide where and how to bind, or what network to bind the VM or the virtual machines to. So we can create public subnets that will be, this will assign an IP that can actually reach the external network, and you can actually reach it from the management network, for example, or use the private subnet where the IP is not advertised and it's isolated, but because we're using the load balancer, we can access it using the load balancer. Other information here, like the global network settings, setting the OS name if it's different from the VM name, setting your domains, and the search domain and DNS server. Now, if you look at one thing here in the Bootstrap, when it comes to bootstrapping and the sysprep experience is pretty much the same thing. There's a guided input where I can use my product ID, the name, and as I go and enable auto login and put the password and the time zone and run the commands. This is using sysprep, but sysprep here in this situation is inline. It's not that horrible XML. If you want also to join, for example, the domain as well, all the stuff will be bootstrap as sysprep inline if you don't like working with XML. But if you are using XML, you can always use the raw configuration and dump your sysprep and attendant text file, the content of the text file in here, which is XML, to bootstrap your Windows machine. So this is just quickly one of the ways of provisioning a virtual machine. One thing I forgot to mention is that at the end of this, you can download all your YAMLs that was generated. You don't really have to write YAMLs anymore when it comes to Kubernetes resource YAML for virtual machines and load balancers and secrets, etc. And those can be saved in source control like GitHub and or GitLab, or used with Argo CD continuous deployment tool. For example, if you happen to want to use Git resource repos as the source of truth. Or we can take that and now move on to the second experience of consumption, and that's through a catalog. Now, there are two types of project users in VCF automation. There's the advanced project user, and then there's the basic user. So low tech, high tech, if you want to think about it that way. The high-tech users, the advanced users, can interact directly with the services, and they can access them in the UI and the CLI and API. But the basic user will not see these services, will not see the namespaces, and all they can see is the catalog. So this is a curated catalog that was created by the project administrator, for example, to satisfy or to fulfill certain requests that the users are requiring. Some users want Windows virtual machine, some wants an Ubuntu Linux machine, some wants a Postgres databases. The consumption using Kubernetes style API is what we are using here. And if we go and peel the onion here a little bit and show you some of the blueprints behind these catalogs, I'll get something super simple, and then I'll show you something a little bit more complex. It would be, for example, what we see here in the canvas. We have all the cloud consumption interface elements that we can drag and drop. This is the namespace that exists hard-coded, for example, in the code. This could be also a drop-down list if we create inputs. And then we have the virtual machine object. But if you look at the code a little bit closely here, and I'll increase if this is too small, you see we have always a manifest property that starts here. And what do we see here? We see the same generated YAML manifest that we saw in the UI, but with a twist. The twist here is that taking that hard-coded, generated sort of a YAML manifest infrastructure as code that was generated for us in the UI and mapping these value into inputs that we can expose to the user, so the user makes the selection, for example. Now I've turned something super monolith and hard-coded into more of a dynamic, where now I can use the same sort of infrastructure as code or the Kubernetes manifest using the Kubernetes style API provisioning and consumption to be able to pass things. So if I go in and look at the catalog and go down to the Ubuntu virtual machine and request this, and look at this, for example, I provide a deployment name, we'll call it demo. The virtual machine name, we'll call it vmug -01. And then here I'm exposing this so the user can select. And these are pre-existing properties that I put into the blueprint to expose these things. And let's go ahead and select VPC public subnet, and the virtual machine size, let's go with it's medium, and then what flavor of images. So very much familiar experience with when we directly use and interact with the services. Obviously, that experience when you're interacting with the services has a lot more control, where the data scientist or the SRE can interact with the service the way they want to deliver a specific use case. But when it comes to certain controlled approach where you have specific options that you want to present to your basic users, this would be the way where the basic users can go into a catalog and select from a curated sort of a self-service catalog to provision the specific images. Now, if we can take a look at something a little bit more complex, I'll show you something, for example, to deploy an open card application. And this is an e-commerce open source application that contains a database running on a VM, but the front end application is containerized. So the front end, which is the web UI, is actually running on a VKS cluster. So with these elements and within the namespace here, I'm able to create my load balancer, for example, to enable access to, this is the SSH and the MySQL load balancer. So the front-end application that's going to run on the VKS cluster or the Kubernetes cluster is going to talk to the IP of the load balancer that's going to allow us to interact with the database and create our records in the database that we're creating under virtual machine. And that's the load balancers. And you can see that we are enabling port 3306 for the MySQL database. Now on the bootstrapping, and this is where I mentioned the inline setup in the UI or the raw configuration. This is my user data. All the things that I want to do on the VM when I bootstrap it. I want to update the repos. I want to install these packages. I want to create these users and include their authorized SSH authorized keys, for example. Write specific files to maybe run some cron jobs. And then all the run commands that I want to execute to set up. Now that I've deployed my MySQL application, I can go in and run all the commands I need to go and at the end create a database called for my open card application. As you can see, these arrows you hear that we can build that dependency to make sure that, for example, this virtual machine doesn't get deployed until the load balancer is up and running. Same thing with the secret. The secret has to be deployed first before the VM boots up, because the VM is going to need the bootstrap to be available for it. On the cluster side, I did not show you the user experience of the UI, but it's the same principle when it comes to the VKS cluster. We do have a manifest, just like the virtual machine, but this manifest now is going to target the cluster kind and all the different options that's available to you to define how many control plane or masters, Kubernetes masters you want to use, and how many worker nodes, for example, you want, and what version in addition of Kubernetes and what cluster class, etc. all these options are also coming from the UI. Again, I don't really have to write a line of code here. I can basically go into my services, go to the Kubernetes service this time, and just like I did with the virtual machine, I can go and create a new Kubernetes cluster. I can literally take the default, click next, and I'm ready to deploy. And my code is generated. So what I've just done is I can copy this to the clipboard, take it to my template, and put it under the manifest with the right indentation, and be able to provision in minutes a Kubernetes cluster that I'm going to deploy my front end application tier, for example, on. If we go back and select if you want a little bit more advanced and custom, where you specify, for example, the cluster name that you want. So let's call this vmug Kubernetes cluster 01. Use the cluster class that we want. Cluster class is going to dictate what features and how we manage the lifecycle of the Kubernetes cluster, and what Kubernetes releases we can actually bootstrap the Kubernetes cluster with. So here, this is using the latest VKS 3.5 that we just released, and I happen to update both the supervisor and the VKS service on my supervisor. So I now have up to version 1.34 of Kubernetes, pretty much much super late. I mean, very recent Kubernetes release. And then as I go down here, I have a lot of options to set my labels, taints, volumes, storage classes, everything, to even including certificate rotation and how long before I rotate certificates, etc. There's also additions, settings in terms of what CIDRs I want to choose for my pods and services, what's the service domain I want to call, unless I want to leave it to default, and what are my persistent volume storage that I want to add, and which of those storage classes I want to be my default. Of course, these are optional. If you don't specify anything, all the storage classes will be available on the Kubernetes cluster. So when you're creating persistent volume claims or persistent volumes, it will automatically and dynamically create these volumes on the VKS cluster. The number of replicas in terms of how many control plane for the cluster, the size of the cluster for the control plane. Let's go medium, and then the backend storage, whether I want to use Photon or Ubuntu, we support both, and down to the node pool, which is really the group of worker nodes. You can create worker nodes for a specific application. Maybe you're creating worker nodes that will leverage the virtual GPUs and the operator, for example, or the RAG operator. So you can create one or more, but you need one at a minimum. And then until you're ready, before you hit finish, you can go in and copy and download the code to deploy this VKS cluster. Same thing with databases. This is assuming that you've extended your control plane, which is the supervisor, to support databases by deploying the data services appliance and operator. Now I can go do the same thing by creating Postgres databases and MySQL databases as well. So here we can select, we'll just say demo, and you can select your database topology in terms of if you want a database level replica where you want to depend on vSphere, HA, and DRS to be the underlining storage to use the underlining storage redundancy, or you want to use single zone AA. This is where we create one primary database and synchronized replica, one monitor. So here in this situation, all the database nodes will share the same vSphere cluster. We'll set the database name and set an admin password. If not, one will get generated for you. And select the namespace again, back to the resource pool where I want this database to be provisioned. Use the size of the database, we'll say medium, and the disk size. Configure the backup details for the database, configure the maintenance window, and set the time. And if there are any additional database option on the Postgres, you can actually add them here in a key value pair. And at the end, you verify the summary and review all the information. But more importantly, I can copy the code and use again the Kubernetes style API to provision my database. And I can use this from here or I can go to the VCF CLI and use kubectl command and apply this code so I can create the database within the targeted namespace. Or again, I can go to my blueprints and create a Postgres database that will allow me to provision this database. Again, back to our blueprint here. I have an existing namespace. I'm doing this in a Acme database resource pool. My database, basically, if we scroll down here in the code, you'll see the manifest, and that same manifest that was generated for us to be able to deploy this Postgres cluster database with as a single database or with high availability or across zones. As you can see, some of those values are coming from certain input. So when the user actually go in to the catalog and scroll down to Postgres database and request that, I can provide a deployment name. I can, let's call this VMware demo. And I can give this a database name, the size that I want, medium or large. And then again, you have this controlled way of consuming a database, or you have that wider control when you're interacting with the with these services directly. And of course, the database version. Once I'm ready, I can submit to provision my Postgres database. So I know we're top of the hour, but I hope I covered as much as I can in this demo. I did share the video series playlist, so please make sure you bookmark that and watch these videos to take you from zero to hero when it comes to VCF automation in VCF 9.
All right, well, great. Thanks, Maher. That was all right. Thanks, Maher. That was great. Thanks everyone for joining, and have a great VMUG.
Thank you.